diagram of the fifth law. The fifth law says the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Now, I've explained what a cyclic quadrilateral is. I said the cyclic quadrilateral is a quadrilateral inside a cycle. This is our cycle and this is the quadrilateral inside it. Now, opposite angle, look at this place and this place are equal. This is the exterior angle of this quadrilateral. This angle is outside this quadrilateral. This A here, from this point to this point, is outside the quadrilateral, not inside the quadrilateral. The law is telling us that this angle here, that is the exterior angle in the cyclic quadrilateral, is what is opposite equals to opposite the interior angle. This angle is opposite to this angle, and this is the interior angle because it's inside the quadrilateral. Why this one is what is the angle, is the exterior angle of the quadrilateral. We call it the exterior angle because this angle from here to here is not inside this quadrilateral, it is outside the quadrilateral. But this one here is what is inside the quadrilateral, so we call it the interior angle. So we said what the interior angle of a cyclic quadrilateral is equal to what? Is equal to the opposite, is equal to the opposite exterior angle. So this A here is equal to what? This A here. This is what this law is saying. Now, the number 6 law says that a tangent is perpendicular to the radius at the point of contact. This is our tangent. Let's say this is A and this is B. Line AB is a tangent. A tangent is a line that just crosses across the circumference of the cycle without entering inside the cycle. Now, this is our radius, this point, this line, drawn from the center of the cycle to the circumference is our radius. Then this is our tangent. Now, the radius is cutting this. The radius is meeting the tangent at this point. This is the radius and this is the tangent. So they are meeting at this point, and the law says that this place is what is perpendicular. That means this place is what is 90 degrees. Alright, theorem 7 says the angle between two tangents to a cycle and a chord through the point of contact is equal to the angle in the alternate segment. Look at the law very well. What does this law mean? Look at the representation of the law here. Let me explain what the law means. This is a cycle, and this is a tangent. Line TQ is the tangent of this cycle. Okay, the theorem states that the angle between this chord, this line from here to here, this line AB is the chord, while this one is the tangent. So the angle between this tangent and this chord AB, this angle, this is the angle between the tangent and the chord. This is the tangent and this is your chord. So this angle between the tangent and the chord, this is the tangent, while this is the chord. So the angle between there is equal to angle in the alternate segment. This is the angle in the alternate segment. This one is the angle in the alternate segment. So this angle here is A is equals to what is here, the angle in the alternate segment. So this implies that whatsoever is in this angle is in this angle. If here is 50 degrees, here also will be what 50 degrees. Whenever you have a chord and a tangent, always know that the angle between the chord and the tangent is equal to angle in the alternate segment. That is what this law is saying. Alright. Now, law 8. Let us go to law 8. Law 8 says two chords P and T and SR of a cycle intersecting outside or inside a cycle at Q. What does this law mean? This is a cycle. This is the cycle. Then we have our two chords PT and RS. From here to here is our chord, and from here to here is another chord. Now these two chords extend outside the cycle. Look at it. This line continues to this point, and this other chord extend outside the cycle, and they both meet at what? At point Q. That is chord PT and chord RS. Both extend outside the cycle and they met at this point, point Q. It implies that PQ, which is PQ, multiplied by dot QT is equal to QR dot QS. So whenever you have two chords meeting outside the cycle to get their respective position. It means that PQ, this PQ dot, when you multiply the answer by QT, is equal to QR dot QS. This is what this two law is saying. Theorem 9. Theorem 9 says two tangents SR and SK to a cycle with the center O are equal. Two tangents, this is the tangent 1, look at it, like this, and the other tangent like this. Now, the first tangent is what SR, from this point to this point. Look at the line, this is the tangent. And this tangent SK to this cycle, look at it. This tangent is equal to, this line here signifies that this tangent is equal to this tangent. Are you seeing it? Now, it does not stop there. It also shows that, look at this point, this angle here and the angle here, they are what? They are equal. And they are also equal to what? Equal to 90 degrees. Now, line SR and SK, they are equal. I've said that one. Now, angle OSR, that we are paying reference to this angle, is equal to angle OSK. That is, this angle and what? And this angle are equal. If here is 70 degrees, it implies that this angle also is what? Is 70 degrees. So this angle here is equal to this angle here. They are equal. Alright. Now, the next one. This angle and this angle are equal. That is SOR. Where is our S? SOR is equals to SOK. Is equals to SOK. This angle and this angle is equal. If here is 50 degrees, that implies that here is also 50 degrees. So these are all what you should know about this figure. Now, we said if two tangents, look at tangent 1 and tangent 2, meet at a point, that means the first tangent is equal to the second tangent. This line and this line are equal. This angle and this angle are equal. This angle here is equal to 90 degrees and it's also equal to the R here, which is 90 degrees. That means the angle here and the angle K and R are equal, which are 90 degrees. Now the angle here and the angle here is also equal. So whatever is the angle here is also equal to what is here. So if here is 50, it implies that here is also 50. Theory 10 says if QK is a secant and QS is a tangent to a cycle, then SQ square is equals to QR dot QK. What are we talking about? This line here is the tangent of this cycle. This line that continues here is the tangent of this cycle. Then this one, KR, line KQ, is what? Is the secant. What is the meaning? Look critically. There is difference between the tangent and the secant. The tangent just cuts the circumference of a cycle, but the secant is just like a chord, that a line that cuts the cycle internal. It cuts the cycle inside. Look at it. Then the secant and the tangent came to meet at a point known as what? At a point known as Q. If you have this, then SQ square, when you square the value of your SQ, is equals to what? Is equals to QR dot QK. QR, the length from here to here, multiplied by the length from here to here. This is what theory 10 is saying. Alright, I'm done explaining the theorems of cycle. In my next chapter, I'll be applying those theories in solving questions, complex questions, complicated questions that look difficult. I'll be using all those theories that I've treated in this section to solve those questions. So you should go and rehearse or practice, make practice of all the theories, so that when we start solving questions, you will not find them difficult. You have the theory at your fingertip. So when we start applying all the theories, you find cycle geometry very, very easy. Now, you cannot solve cycle geometry without knowing all these theories. Most people may not actually itemize all these 10 theories but I took out my time and figure out all these theories. Theories is not as much as this, but I took out my time to separate the theories so that when we come to solving cyclic geometries, we will not have any problem. I won't understand all this theory. So that's what we are going to be doing in my next chapter. We are going to be solving plenty questions on cyclic geometry using our 10 theories and applying them. Alright, thank you very much for watching. Please like, subscribe to my channel. Thank you.